Welcome everybody to another BIM broadcast. My name is Shawn I'm the technical evangelist at CTC, and today I am joined by Buck Davis from BIMBOX USA, and we're going to be talking about some graphics cards, your workflow in the world of BIM. Buck, welcome to the show.
Shawn, thanks for having me, man.
Hey man, we were having a little bit of a pre-show discussion here, so we started about a minute late, but the goal today is we're going to be talking graphics cards as mentioned. And you last night spent like a few hours doing some seriously deep digging on graphics cards to get us the inside info, right?
I did, and it's been a while since I've gone down a wormhole like that. You can start on something, and graphics cards take you down it. I mean, when you start thinking about all the different specialized use cases and all the different functionality on a graphics card, it's really an amazing piece of hardware.
Oh, by the way, guys, we are always watching that chat window. So when you pipe in and say hello, we're going to try to say hello back. So Matt, you just said hi. What's up, Matt? How's it going today? So Matt was, I believe, one of our winners from one of the computer parts that we gave away. What was it he got? Was it the full laptop?
He's getting a 2080 mobile laptop.
Dude, that is awesome. So just so you guys know, we're usually doing giveaways on this show. If you show up for the live show especially, you have the best possible chance of winning. And we're going to probably talk about some of the giveaways that we have up and coming as well. So that'll be coming later. So Buck, let's get into the discussion here about graphics cards. I got a ton of windows pulled up over here in my other monitor, and we're going to go through a few of those. But before we do, let's start just kind of giving an outline for the show. We're going to talk about hardware differences. We're going to talk about API differences. We're going to talk about what RAM and processors on the hardware, all kinds of different topics today, right?
Most definitely, and I think the place where we start is why the graphics cards kind of come about. AutoCAD CAD design was one of the first real use cases for this, and the designated graphics card was kind of birthed from the fact that using the CPU to render out images drained your resources, and the other performance problems with other issues in softwares.
Exactly. So those of us who started in the world of AutoCAD, guys, we were the pioneers for dedicated GPUs, and it's because it was necessary, so that's great. Now, though, we're not really in the world of AutoCAD anymore, and our needs have changed a little bit. We're not just drawing lines, arcs, and circles. And take a break for a second. Hey, Rob, how's it going? Good to see you in the chat stream there as well. So we don't need more than just lines, arcs, and circles on the screen. We're rendering in 3D in some cases, or we're rendering in some cases. We're spinning models around in 3D. We're doing lighting calculations. All of that is a stressor on the GPU. And so depending on what your focus is, you might need a different card. It's not all just one size fits all, right, Buck?
Right, and I think there's all of it's symbiotic, and I think when we look at this, it kind of depends on the card you're using, the hardware you're using. Right. The in between, which is going to be the language and the either OpenGL, OpenCL, DirectX, or Okuda nowadays, and how well a software program, efficiently uses those API calls to stream that entertainment environment. It kind of is a play across that, because you could have the best card in the world, bad programming, and once again we have a bad experience. And I think that's one of the things that we're seeing right now in our industry with all these real-time rendering, for Revit, the Enscapes, users, and other things, that you're seeing people kind of race to get this efficiency in rendering out our 3D Revit models and other modeling solutions, leveraging the GPUs a lot more than we previously had thought to.
Yeah, so, and once again, just like we've been saying in most of these shows, guys, it's not one thing that drives your performance. It's all kinds of things, and it all depends on how you're planning on using it, right? If you're not doing any rendering, you need a vastly different card and well, not a vastly different processor, but different quantities of RAM. And if you're not doing Navisworks or you're not doing point clouds, it all plays a factor. And today's discussion being on the graphics card, obviously we're going to focus heavily on that. And so we're going to be talking a little bit about just direct modeling, but probably a lot about the rendering side, because that's where graphics cards really play the biggest difference.
Yeah, Shawn, I think the first step when we're looking at speccing out the graphics cards for us, because AutoCAD and Revit are not heavily rendered. And as much as we talk about rendering images, I see 95% of our clients are sitting looking at AutoCAD or Revit line work, right? That's not a real intensive environment. I mean, you do get big models, you do need the refresh rate, but we don't really need to get into the exotic $3,000, $5,000 graphics cards, which is kind of a dynamic shift, right? You know, I was speaking with Anthony, our head of production, kind of R&D on this, and asking him, you know, for the show, what's the first thing you look at when you're speccing a system for somebody? And he said the number of ports, right? How many monitors are we going to be pushing out to, and what does that look like? If you want 4 monitors, you know, a 1060 is not going to work for you. Or excuse me, the 2060 is not going to work for you. So that's why we started at 2070. Really great for line work and other things. And then we start kind of building off what else are you going to try to do? You know, do you plan on doing some V-Ray rendering? Are you using Lumion? Are you using Inkscape? And all those things tax the GPU a little bit different. So we kind of have other things in play, and we'll get into that. But I think, you know, the first thing we see often a lot is people getting scared that they're not getting enough graphics card, when in actuality, Revit is just line work. I mean, you're not looking at ray tracing and textures with different lights and shades. We're just representing line work, right? So the first step is don't go overkill. You know, and one of the things that I think we have to touch on, it is kind of a stigma, and I think we had a pretty good article that we posted yesterday before the show about, you know, do you need a professional graphics card? And what the hoopla is about that. We'll go later in the show and kind of show you side by side, you know, a GeForce, or excuse me, RTX card, consumer card, versus its Quadro professional version. But you know, when we look at this, and this is, I'm a huge X-Files fan, so this kind of had me at hello. Some of the things that we look at in here is just, you know, what makes a Quadro card different than a consumer card. And the bottom line is it comes down to the drivers. And those drivers allow accelerated graphics to go across that card, right? So depending upon what the software is, and before we get too far along, let's talk about that, right? How does a computer interact with graphics card hardware the way it stands? It does it through APIs. And there are a couple out there. The first one that came out for AutoCAD, not for AutoCAD, but the first one was kind of birthed through AutoCAD, was Opengl. And Opengl was, and it's still cross platforms. Anytime you download your drivers for your AMD card or your NVIDIA card, you are downloading the most recent version of Opengl. Opengl, the beauty of that was it wasn't platform specific. So you could use Opengl on Linux, you could use it on Mac, you could use it on Windows, any operating system out there. And that was really advantageous for software designers because you don't have to make different versions based off operating systems. It's kind of universally used. Then Microsoft came out with DirectX, which was exclusively for Microsoft, and that was to do 3D graphics inside the Windows environment. There was about a 5 or 10 year race to see who was better, right? It was like who could be the first, you know, Blu-ray versus HD. And Microsoft, for all intents and purposes, won. And a lot of that's due to the fact that the majority of people use Windows. Now we see, you know, NVIDIA dropping the CUDA platform, which is really focused on, I mean, right now it's machine learning, AI, computational accelerations, and that's really the primary focus of the business. So when we look at that, we think about, you know, the Quadro drivers, what ability do you have? And if you look at the list of the enhancements that you get, a lot of time in our industry, we're sold on, well, you know, it renders scenes better, and debatable. We can have that debate, and we have benchmarks to back it up. But when we've seen Quadros have a really good, it's double float point, which we'll get into performance when we're trying to render out a photorealistic animation. And when we think about the users that are actually taking advantage of that, we're thinking Steven Spielberg, you know, we're thinking Disney, we're thinking all these Pixar animation centers that are trying to render out an hour-and-a-half movie in perfect animation, right? That's what those cards are made for. Having said that, it's very easy to say, well, they are the best thing for AutoCAD. But in my experience, and I'd be hard pressed if anybody wants to jump in the chat box and disagree with me, I'm happy to pull up some benchmark numbers. For better line work inside of an AutoCAD or Revit environment or an ArchiCAD environment or SolidWorks, 3DX modeling environment, you're not getting any benefit out of those hardware accelerations. Okay, and that's kind of the one thing we see when you put a GeForce card, or you put an RTX card, a consumer card in. First thing that pops up when you open up Revit, right? This hardware is not meet the requirements of hardware acceleration. Performance may be great, and I kind of say shame on Autodesk for throwing that out there, for the fact that you can have a wonderful experience. We were actually even debating it last night. You could put a 1070, an old, dated GPU from NVIDIA in one of our Striker systems with a really high performance CPU and RAM, and you'd have a good experience, right?
And that's
you might have a little lag.
Because, like you said earlier, it's lines. So you don't need that super high end. Is it the best? Sure, it's the best card. And some of those cards out there are the best cards, and they do great for the Disneys and the Pixars of the world. But none of us are really, not none of us, very, very few of us are taking advantage of that. So
completely,
it's a big consideration when you're speccing your system out. Like, do you want to spend $3,000-$4,000 on a graphics card and get the best of the best and never take the benefit of the capabilities? That's like going out and buying a Formula One racer and then trying to drive it on the freeway. I mean, you don't need a Formula One racer on the freeway.
Right, and so I think it's important, when you're looking at your applications that you're using, we always go to recommended specs, and some of the things that you want to look at. And nowadays, it's kind of been dumbed down to where you don't even have to think about it. There was a couple-year period where you could choose to use OpenCL rendering or CUDA rendering or even DirectX, and you had an option. Right, nowadays, it kind of defaults to the most optimal API calls. But it really is, and I think people need to kind of understand when you say you're using DirectX, that's just the language and the calls that are being used to transfer data from your CPU to your graphical processing unit, and then from there, it's using those API calls to actually render out the image to your screen, and that's extremely important to kind of look at. There's some different things inside of here, and Shawn, I don't know if we want to go towards rendering engines or gaming engines and how they leverage things and how they create it, because I think we found a really good article in here that kind of walks you through how you create a gaming engine. Right. And I think for the purpose of the drill, it's interesting to read that because you'll have a better understanding of what's happening on the GPU, right? How it's using shaders, what a textile is. And there are a lot of people out there, if you're geeking out on VR and you're geeking out on real-time rendering, this is a wonderful article, and I'll post this up on the blog afterwards, to kind of walk you through what's actually happening when you create a rendering engine. And to be honest with you, man, after I read this, I was thinking about Thomas and Moritz over at Inkscape, man, and those guys are actually just amazing when they get into how they use shaders and how they use different information to make that scene happen quickly, right, and be elegant and beautiful, and to run on all kinds of different graphic cards well. So there's some magic going on in the background on some of these programs, and I do want to give a shout out to those guys for making something as efficient as possible. But we kind of get into two different things, right? When you're rendering, what is it doing? We're talking about floating point accuracy, single, double point, and so on. Where you see a Quadro card, since we brought it up, really take advantage of some of those cards is on the double float accuracy. So when we think about this, and I don't want to get too far into the weeds on it, when you're trying to represent decimals and binary, right? There's some decimals that are hard, like 2/3, right? That's 0.66 forever. How does the computer describe, right? How does the computer use 2/3 as a binary decimal, as a decimal to describe something, right? So we have to make some assumptions, and the computer has to make some assumptions on where we round those numbers off and what happens. So for forever, we've had 8-bit color schemes, and now we have 32-bit, which is going to be the single floating point. When you think about that, and I actually was geeking out on this last night because I'm a huge fan of TVs, and just to kind of share this, I have a 4K Ultra HD monitor back here. So the 4K is going to represent the number of pixels I have. The Ultra HD is going to be that 32-bit processing color. The great example in the articles that we read were kind of, if you looked at the sun. Don't do this, but if you took a picture of the sun, the image on your phone would look like a white spot, right? That's because it doesn't have the ability to capture all the different colors that are going on. They're different shades of white. They're different shades of yellow. They're black. I mean, there's black, there's red. And by opening up from an 8-bit to a 32-bit, which is the single point float precision that we get on all the graphics cards that we have, you have a much wider range of colors. You can be whiter than white and blacker than black. And that really is one way to describe what's going on in your system. Double precision just gives you a wider array of that, right? It also slows things down, which is why on a lot of the real-time rendering solutions you won't see double float point. The cards are not capable of maintaining that during the rendering environment. You see a lot of that in post-process rendering, which is a great place for Quadro cards. But if you're not doing post-process rendering, it's hard to weigh the cost to performance value on that.
Right. And I want to jump in a little bit right there also and kind of talk about the real needs of the person, because right now these days you get a lot of people buying like 4K monitors on a 15-inch laptop. Are you really gonna see 4,000 pixels in the difference? Is it really gonna be that big of a benefit to you? If you've got a 27-inch monitor sitting next to you, are you really gonna take benefit of a 4K monitor and spend that extra money and get the graphics card to drive it when you're drawing in Revit or you're drawing in AutoCAD? I don't think you are. I don't think that's possible. Like on a TV, man, when you're talking about your TV back there, you're watching a movie and you got like a 60-inch screen or something, absolutely. You get the benefits. If you're outputting a rendering to that, fantastic. You're going to get the benefits. But if you're in like VR goggles and you're trying to use a 4K, what's the point? VR goggles can't do 4K right now, as far as I recall. Your desktop monitors, you're just not going to get the benefit. So again, it's a benefit thing. Like, are you just trying to say you got it so you got it? Or do you really need it, and do you really need that power to push it, right? We're talking about all this graphics card, like floating point, depth stuff at this point right now, but really, when you guys are working in Revit, when you're doing building information modeling, when you're creating this information, if you're doing this for the purpose of drawing, and I'm keep bringing this back to the baseline, because we're going to go out in the weeds many times through this discussion, but oh, so many of you don't need that, right? And that's okay. It's not like we're talking down to somebody going, oh, you're not using the 4K. So what? It's not relevant to you, right?
No, and I think that's one of the things. Like if I had to make a recommendation, if I was going to build someone a really good BIM workstation, and I think we see this sometimes, people are going and they're looking for that CPU, they're looking for the GPU, and everything else kind of is secondary. I one of the reasons our base spec or our recommended spec on our Striker system is a 2070 is because that's all you need. Right. we don't want to overkill you on graphics and the cost drives up and everything else. We'd rather see you get 64 gigs of RAM than jump into a 2080. And I think that's kind of something that's kind of, it's an ebb and flow, right? When everyone realized when virtual reality came out and real-time rendering came out that their K4000 or M4000 wouldn't do it, all of a sudden it's like, well, now I have to get the best card out there in the world. I don't want a crummy experience. And now we're having this kind of come to Jesus meeting where it's like, okay, we don't need Quadros. We probably don't need the Titan. What makes sense for us? And I think that's where we kind of get in the 2070, 2080 range. And there have been some interesting, I think when we talk about graphics cards, we can talk about, the ports, the speed, the clock speed, and we'll go into some of that. But it's really kind of interesting to look at what's coming down the pipeline and to go into, to the kind of variations, because for a long time, I kind of was of the belief that, the professional graphics was dictating, where things were going. And now it's more the artificial intelligence and machine learning. And the reason we got to be mindful of this is we're hardware. What's driving the innovation in hardware, right? If machine learning and AI is the future, trust me, NVIDIA is pivoting, heading straight towards machine learning and AI, which you're starting to see in some of their graphics cards. These new 2080 series RTX cards actually have cores specified for AI rendering, right? To have some artificial intelligence to figure out how to render out a pixel. Right now, from what we're hearing, they're still a little ways behind. Their current algorithms to render are actually better and clearer than the artificial intelligence. But just to kind of put that out there in the world, if you see those Turing sensors, Those are made for AI to render out a scene for you. I think you're going to see some lag time between, when an Inkscape or when a Fuser or when a V-Ray actually, integrates that into their software. Because remember, the software has to use those files efficiently, accurately to get them to have any benefit. The reason that the GPU, and Shawn, going back to this, it was created was to offload rendering from the CPU to a GPU. And one of the things that we kind of constantly hear is that a GPU can compute 10 times faster than CPU. The reason that is it's specialized in computation, right? A CPU is made for task, a GPU is made for rendering. So you're sending data down a pipeline that is extremely fast and can accelerate certain calculations, but you got to be efficient with those calculations. Exactly. So, I think we're seeing a really, really cool stuff coming out of the pipeline. I think right now we're kind of in this lag of the hardware probably can do more than the software is taking advantage of, but the hardware comes out every 6 months. How do the software companies stay up to date with the latest and greatest without having 2 engineers sitting there trying to maximize algorithms based off what comes out in 6 months? So this is where we kind of get back to the basics, man, and really right. Looking at what's best for Revit.
Well, let's do that. Let's get back to the basics. Let's talk the core, like super simple basics between a Quadro and a G-Force. Let's do that. I did a little bit of my own research and I went like super basic, okay? Quadro seems to be better for rendering. If you're doing high-end rendering, seems like Quadro's supposed to theoretically be better for that. It has a little bit more power for the rendering. Like in my case on my laptop, the one that actually was given to me by BIMBOX, this thing has a Quadro card in it. Am I right? It does have a Quadro. I'm pretty sure I checked that out ahead of time. It's got a Quadro, and it's great because I'm able to take this video streaming that I'm doing right here and drive it where my previous laptop was lagging like crazy. It was having all kinds of difficulty because all this is being processed through the graphics card. What I had before was a G-Force. It was good enough for Revit. It ran Revit great, but it wasn't great for this video production. It wasn't great for doing recordings and videos and things like that. And also 3D creation, as I understand it, the Quadro rather seems to be better, generally seems to be better at that. Whereas the G-Force it's got technically faster clock speeds, right? So it's theoretically faster. It's better at you get more options for multi-monitor controls. If you need to have greater quantity of screens, in my case I'm running a total of 3. I'd love to run 6, but this doesn't have the ability. That's not spec for that, and it's a laptop. And it's really great for budget CAD. You don't need to spend a lot if all you're doing is CAD. So the G-Force seems to shine in that area when all you're doing is CAD. Did I basic that good enough, Buck?
You definitely did. And I think that there's some of the stuff we've been discussing that kind of highlights that. Typically when you look at a Quadro card, and not so much with the newer ones, it had a lot more RAM on it. And a lot of that comes down to that floating point, right? A 64-bit piece of data is almost twice as big on your RAM, right? So you need to have more RAM if you're planning for that accuracy.
So that power comes into play.
Yeah, and it's tough when you look at benchmarks because not many benchmarks actually max out the RAM on a GeForce card, right? So being fair, as much as I'm a GeForce or RTX person, if we had a 13 gigabyte scene and we tried to run it on a 2080 Ti 11 gigabyte card, and then we had the counterpart, the Quadro, 5000 RTX, the RTX would steam through it because at some point we just hit the headroom on the RAM on the card. Right. The reason we don't really see that is we never run into that on our models. If you take, and I had a client send me a 2 gigabyte Inkscape executable, it still doesn't even come anywhere near taxing out, the RAM on the GPU. So one of the reasons that we constantly say when we look at it, the best choice for us is that clock speed. So if we pulled up two different, and I think you might have them, let's just look at two different graphics cards. If we had a Titan RTX versus the P6000 or 6000 RTX, and we do side by side on them, let me see, platforms, yeah, Titan RTX.
Titan RTX, we're gonna pull up its specs here.
Top specs.
Specs.
It's on the top bar. Yeah.
Oh.
Okay, so if we look at this, it's got 6 graphics processing clusters identical to the 6000. It's got 72 screaming micro multiprocessors identical. The CUDA cores, which is really important, is 4608 identical. Tensor cores, I believe we have 576 on the Titan RTX, and we have 588. Let me see what that is. Actually, tensor cores are the exact same. The only place that we're going to see a discrepancy is on the RTX cores. We have 72 on the Titan, and I believe 82 or 84 on the Quadro card. 84. The RAM is the exact same RAM. The teraflop single point precision is identical, and we have a higher base clock rate. So unless you're running out of 24 gigs of RAM, this is going to be a card. It's half as much money, the exact same specs, identical card. And one of the things we're going to talk about is when you look at those CUDA cores, single precision, when you are in a program like Inkscape and you start panning and it kind of blurs a little and then it registers, it comes back to looking very clear. That's those cores hacking away at that rendering, right? So the higher the clock, same number of cores, you're going to have a better experience. And that's why, on a lot of these real time, we say this is just a better card. There are some instances we could talk about, where, and this once again goes back to the professional rendering, one thing that's not available on this Titan RTX, or it's kind of available but not as, is the Quadro card. You can put 2 in there with the NVLink and then have technically just like two Xeon processors in your computer, 2 processors working together as one. We've actually done that with some of the 2080 series. We actually posted one earlier. It's 2 2080 Ti's in tandem with the NVLink card. They're now actually offering that bidirectional in the 20 series graphics cards. The one thing that we noticed is we have an actual performance degradation, right? It doesn't do as well on some of the benchmarks like V-Ray. But then again, we haven't tapped out the 11 gigabytes, right? If we had a benchmark that would run 12 gigabytes, the dual cards would work better. So that's negligible. I mean, if you're out there and you think you need 2 graphics cards, give me a buzz. We're happy to sit down and have a conversation of why you don't. But having said that, there are instances. Well, let's think about this. Anyone out there that's using Lumion, right? If you start animating a scene with Lumion, it's using every bit of your graphics card, right? Then you have to sit there and do Revit. You're not having a great experience. So if you were having 2 graphic cards in your Lumion system, you might have a 1060 running Revit and then a 2080 Ti actually doing the rendering in Lumion, and now you're having a great experience while you're also animating a scene. So being mindful of what you're going to do and what you need in the system is very, very important.
Right. Matthew asked a question over there in the chat. He said, which is better for display configuration, GeForce and Quadro? I asked him to clarify a little bit, but if you're trying to, are you talking like display configuration for Revit? Are you talking display configuration just on a computer in general? Settings? What are you looking for there, Matthew? We'll kind of answer that live once you get back to me on that. But so if you have multiple displays, which handles those configurations? Oh, the configurations of the cards, the configurations of the cores and the graphics options. Which one do you think is a little bit better for that? Let's see, again, that's a little vague for me in general.
Well, so we do have a client, Cody Nowak. He's doing BIM cubes, and they're doing stereoscopic 3D VR, right? And that's one of those instances that in order to get him 6 or 7 throw projectors in that complete panoramic phase, that's a Quadro driver lock. You have to have 2 P6000s and they have to have an NVLink in order to actually get the stereoscopic VR. I mean, that's the only way you can do it. And that's one of those instances. That is the only instance that I've run into where we had a software that actually would not do what we wanted it to do unless you bought Quadros. And Cody's building monster systems out there. But as far as handling, how we're sharing screens and whatnot, they're identical cards. They have the same ports and plugs. And actually, let me take that back. That's not true. I have to check on the new P6000 RTX. But the old P6000 actually did not have the HDMI ports that its Titan RTX does, right? So if you want to do VR, you were kind of tapped out. because we all know you need 2 HDMI cables to do VR. So that was kind of one of those things where we got a rub on it, right? If that Quadro was the better graphics card, you know, for VR, why was it not equipped with the correct ports for people to do VR? So, you know, we're still getting a little rub. I don't think, and to answer your question, they handle them both very well. A lot of that's happening depending if you're in Windows using DirectX. You're not using CUDA core acceleration, and neither in Revit either. So you're going to get the same performance.
Right. All right. So you mentioned a couple of times API. We've talked about the 2 or 3 different API type calls. I want to, before we jump into this again, API for everybody stands for Application Programming Interface. It's the way that the developers of graphics tools interact with this platform, with this program that tells the graphics card how to do what it's supposed to do. So by having this standardized environment, by having Opengl or DirectX or what was it, CUDA? No, what was that? A third one you mentioned? Yeah, CUDA.
Opengl.
Yep. By having those 3, you have 3 different standards, so to speak, of ways of interacting, and they handle the graphics in slightly different ways. So the card itself has hardware. These 3 little interaction methods, the Opengl, the DirectX, and the CUDA, allows the developers to talk to it. The more efficiently those tools are, those APIs are, the better off the program, like Revit or Enscape or whatever, is going to communicate. Developers do have the ability, if they want to write their own graphics engine. They don't have to directly rely on those 3, but I think most of them do. I mean, writing a graphics engine, again, if you wanted to know more about writing a graphics engine yourself, we brought this up a minute ago. I'm going to merge this back across here. How does a rendering engine work, right? How does, you know, in this case, we're talking primarily Opengl a lot through this article. But if you go through this, it talks about all the different features of the things that have to be rendered. How to take a scene in a 3D environment and convert it to a 2D graphic on a screen. That's basically what's happening. We perceive it as 3D. The screen has to render it on a flat interface. And so all of this information here in this article is talking through how the different tools are using, in this case, Opengl, to do that. And I think a little later on, there was also a discussion about how DirectX does some extra stuff in here. I can't locate it very quickly here, but no, it's all Opengl. All right. But yeah, fantastic information if you want to know more about how this actually works. But again, the software that you're dealing with has to communicate to this properly, use the proper drivers to make this as efficient as possible so it can actually leverage your graphics card.
Well, and there was a time period, just to kind of go through this, where, and when we say a Quadro is accelerated, has hardware acceleration, that's done through drivers, right? So when NVIDIA's compiling code, right, and then people were building off that CUDA environment, right, using their API calls, there are specific calls that a Quadro card will be able to access that a GeForce card will not. They're physical replica cards. So, you know, that's why when we kind of look at what would that be, you know, and there are different reasons, different people do different things. Like I know that, you know, we've looked at some companies that use OpenCL, which is Open Computer Language. That's actually API calls where it's hardware agnostic, right? That information, once processed, can be processed on a GPU, CPU. There are quite a few different things out there. It kind of becomes data agnostic just for computational purposes. And we've seen some programs, I know Pix4D and a couple others, where it just uses every ounce of everything you have in your system to do all calculations. It's extremely parallel. So, you know, it really comes down to, for the most part, the software company's ability to leverage that hardware and those API calls. But, you know, depending upon what they're using, and it's not as big of a deal anymore because most programs are meant to run all those different things. You know, a lot of the times you'll see now, while CUDA is there, a lot of gaming companies have to still program, you know, for OpenGL because CUDA does not work on an AMD card, right? NVIDIA does not allow AMD cards to run hardware accelerations on their software. And it gets a little bit more in the weeds if you look at that. Some of the interesting things that we were looking at last night, Oh, and it gets down to how these different graphics cards compress data, right? So NVIDIA, when they moved to the new HMB2 RAM, which is kind of seems like they've scrapped, everyone spent all this money developing this new type of RAM, and then found out, one, it's extremely expensive to make, and it's extremely hard to make well. So, AMD, they don't have a great compression algorithm on the graphics card. So when data hits there, it kind of blows up a little bit. It took great advantage of the faster RAM. If you look at NVIDIA's new stuff that's coming out, they're using the GDDR6, which is a dated product, but they're getting better bandwidth throughput because they have more elegant software. It's compiled better. And so when we're making decisions about that, there's some trade-offs on there. Right now, and I think, Shawn, I'm not a huge AMD person. If you're looking and you need the professional graphics series, there's some really, really good cost-effective AMD professional cards out there that have this killer HMB2 RAM, have tons of cores. And for professional rendering, I actually make a stab at one of those. They're cost-effective professional cards. If money's not an object, though, always let's get the 6000 RTX. Let's put NVLink on them, and let's get 3 or 4 in a row, right? But that's not for our typical users, right?
No, and also, you were mentioning about how some of the cards themselves, some of the API calls, they don't like to leverage that hardware acceleration.
Correct.
A lot of the programs, AutoCAD, Revit, there's a few others out there that actually in the options let you disable the hardware acceleration. By default, I believe it's on, so that you could try to take advantage of that. But if you're seeing problems and it's causing some conflict, you can disable it if you need to, if the card itself isn't supporting that.
Yeah, and all these cards, I mean, when we look at it, when was the last time the Revit graphics engine was updated? I Googled that last night.
Oh.
I Googled that, and I didn't, it came back with a very slim number of answers and lots of support line help and other things and stuff. But, OpenGL for the longest time was the way to do that. It was highly effective, highly efficient. It ran on every system out there, and it's embedded in every card we have right now. So anytime we kind of hear, oh, those cards won't work with AutoCAD or Revit, we're kind of like, well, does it use OpenGL? I mean, is there something that you took away from that card that it's not going to be able to use open graphics language, the most standardized language in the world next to like DirectX? But that really is what it comes down to. And I think, as we continue to evolve, the question kind of comes out, what will make a better Revit graphics card? Do you always need to upgrade? And I think that's kind of becoming one of those big question marks is, does it make sense not only to buy an expensive graphics card, but to use a newer series, right? I don't know if Revit or AutoCAD have any plans to take leverage of the tensor cores for the AI on the new NVIDIA graphics. I don't know. I couldn't find it in Googling last night. I went down a couple wormholes. So,
I mean, if you're using something like 3ds Max maybe, or Maya maybe, or some of the other 3D tools out there, again, that's where you're going to maybe get some of that benefit. But if you're using Revit or AutoCAD Civil 3D, AutoCAD Plant 3D, whatever, I mean, you're not going to necessarily need to buy a super high-end card. We said that a couple times in this show, but that's just the truth of it.
And I don't mean to keep driving that home, but I think without getting too far in the weeds, when you're looking at a good graphics card, you want a lot of cores, you want a lot of clock speed, and you want the highest speed RAM you can get. A lot of what's going on when we're seeing a lag, when you start painting around a model and you're lagging, is one, the data that's on the graphics card, it's not able to get to the GPU fast enough, right? And we have the same thing with our desktops. That's why we put really high performance RAM in, and that's why we overclock the processors as fast as we can, right? We want to crunching the data that's fast, but they also need data availability. So when you're specing out these graphics cards, and Shawn, I think if you could pull it up real quick just to take a look at one of those GPUs as far as the spec sheet, if you still have it, this is really kind of what you want to look for. You want to look for the CUDA cores, the CUDA parallel processing cores is the #1 thing. That's going to be the equivalent of your 9900K having 8 cores, 16 threads. Your clock speed, which they don't really show you on the Quadros, wink, wink.
Right.
You're not going to see clock speed on this because then people would do side by sides with the Titan RTX. On there, you're going to see your base clock and your boost clock. That's no different than a CPU saying, 4.2 boost to 4.8. If you're doing heavy workloads all day long, you're probably going to see somewhere in between that. Your memory clock, and this is debatable. Some people on our build team would disagree with me, and they're not here today. As far as what the memory clock is, when I started getting into overclocking, once you do a CPU, you're like, what else can we overclock? And then you go RAM, and then you get to a graphics card. Memory clock is important as well. That's how fast data can get to the RAM, read the RAM, and then feed it, and then do it again. How fast can we just keep information reading, writing to those? So in a lot of instances, that memory clock is important, and that's one of the reasons you're seeing a really high clock speed on these graphics cards. The last thing we're going to look at is going to be the total memory, the 224 gigabytes GDDR. Not as important for people doing what we do. Anything 8 gigabytes or more is fine. 24 gigabytes, and this is, Shawn, one of the things that kind of threw me for a loop. Typically, you never saw a consumer card going over 12. I mean, right. The Titan X, Titan M, Titan XP, we're all right there, 12 gigabytes of RAM. 24, you're now kind of almost identical to a Quadro card, which that was kind of always one of the sell-up features to a Quadro, is if you need more RAM, you have to go to Quadro. This, we're not really seeing that, which is kind of an interesting, it had me kind of questioning, and we had some really good discussions last night about it, as far as what is NVIDIA doing with these cards. And I think everything that I can tell is that the Titan RTX is kind of an entry-level hacker's version of machine learning, right? If you don't have a data center, a supercomputer at your university, and you're at home trying to hack away with some machine learning and AI, you're using a Titan RTX. So this is kind of where we're seeing the blur between different products.
Yep.
And I think we're going to kind of continue to see that. And I'm interested to see where NVIDIA goes with this. It doesn't seem like it's as apparent because, right now they have the Titan RTX, which we just saw with 24 gigs of RAM. Then we have Titan V, which was actually released to be AI and machine learning, which only has 16 gigabytes of RAM. And then you have the Quadro, which has 24. So there's kind of a discrepancy right here. One costs $2,500, the Titan. One costs $3,000, which is the Titan V. And then one is a $5,500 card, which is the Quadro. So, I think it's interesting to talk about, but once again, I don't think very, very few users will benefit from that. We have built hundreds of systems, and we've used dual Quadros 4 times, and that wasn't because people didn't ask for it. We couldn't help them rationalize the reason for needing it. We've done dual Titan cards more often than not. We did a killer Pix 4D system with dual Titan RTXs in it, and Pix 4D uses OpenCL, so it uses your processors and your graphics cards. Load that thing up with the Titans, and you have close to 1,500 cores processing out your photogrammetry. So I mean, it kind of comes down to use case, but you can get a good system without spending that much money. I think once again, just to reiterate, if the myth is you need professional cards, that myth should be debunked daily and often.
Right, I agree. Now, Matthew actually sent in a question. He said, when you're orbiting around in a Revit model, isn't that more CPU dependent than GPU dependent? Are you really taxing the GPU when you're in a Revit model orbiting that around in 3D? And I don't recall the answer.
So the quick test that I would say to do is Revit runs fine without a designated graphics card, right?
Right. You
can run Revit on the surface and have a pleasurable experience. Anytime I ran big models on a surface, or anytime we run big models without a designated graphics cards, we do, and when I say big model, we're talking 850, megabytes to a gigabyte. We got a lot of laggy, static kind of painting around. If you have a designated graphics card, it will leverage that to smooth out some of that and keep the refresh rate up.
Right. And that is primarily because Revit is not OpenCL, it's OpenGL, so it is using the graphics card. And the better your graphics card, to a certain degree, the better you're going to see the painting in Revit on the screen. Especially if you're doing like a shaded view, you're doing like a realistic view orbiting, you're doing shaded view orbiting, even hidden line, you're going to be hitting the GPU in that case. The CPU is not really designed, and that's the whole purpose of the GPU, is so the CPU can offload the graphics processing. If you are using that onboard graphics like Buck just mentioned, yeah, you're going to be okay in a reasonable model. You might see some jitter, you might see some like shaky panning, but it'll still be fine. Revit's optimized its graphics engine acceptably for its environment. You're not really going to tax a GPU, but you are going to tax a CPU a little bit if that's all you got, if you're using shared graphics. It's not ideal.
Yep. And you're also not using your processing resources. So, you know, Revit doesn't have all the bandwidth from the CPU to actually do Revit. It's working a lot of that.
Anyway.
Yeah.
Right on. Let's see. How in the weeds do we want to get today, Buck? We've got about probably 10 minutes more. Is there some topics we want to cover real quick before we're done? Or should we talk about graphics card to motherboard interaction lightly before next session's motherboard full discussion?
Well, you know, I think we should get into, because I know a lot of the people might be doing VR right now, right? Virtual reality, and that's extremely taxing on a GPU. And there's some interesting things, you know, if you get into texture filter rate, which it's an important figure. I mean, if you go to a graphics card, look at the specs, and every one of those specs that they give you, Google it, right? What actually gives you a great experience in VR, and there are actually some interesting spreadsheets on Oculus and Vive where they go into what the texture filter rate needs to be in order to maintain the frame rate required to have a good experience in there. When we first started getting these beefed up systems with the higher end graphics cards, you can actually do something called super sampling, right? So texture filter rate is how many pixels a graphics card can project or process in a given second. Okay, so you can only think, when you're doing VR, you're trying to project tons of pixels. And it's not just pixels, it's also texels. And texel is a pixel that has not been turned into a piece of information to go to the screen. So when you're doing VR, one of the things that's tricky about that on a graphics card is it might be able to keep 4K on dual monitors, but VR is not 4K on dual monitors, right? Because it has to be rendering out, if you look left, what's left. If you look up, what's up. Otherwise, you start to get lag. So that's where that texture filter rate is going to come in. One of the things you can do is super sampling, and this is if you have a really beefed up designated graphics card, and you just be wary, save your log file first, is you can Google this, go super sampling on an Oculus or super sampling on a Vive. If you have an extremely high texture filter rate, you can go change your multiplier on your resolution. So you can send a higher resolution than natively accepted to your Vive headset to have smoother imaging. You just have to have a high texture filter rate that can accommodate that. There's a journal file. If you Google it after this, try 1.1 as a multiplier times 1.2. On a 2080, 1.3 is kind of the cap, especially if you're doing like a 2 gigabyte file. But if you've ever had laggy experience in VR, this is a great area where you can play around with that. And this is where buying one of those more high performance graphics cards can make a big impact if you're doing virtual reality.
Right. And that's because it's rendering so much more. It's holding more in the GPU's memory. It's needing to very rapidly get information. As you turn your head, it has to instantly respond to that and then start rendering what's next in the frame. What's to the opposite side, what's above, what's below. As you look around, that has to be all live rendered. That's the whole point of VR. And it does take something much more beefy there.
And it's interesting because when you get into, and not to jump back to it, but this is kind of where, when you look at your texture filter rate, a lot of gaming engines have to kind of make a judgment, and we actually use the term LOD, right? So if an object is within 20 feet of said screen or camera, we want to render it at this LOD. If it's 100 yards in the background, We don't want to spend as much time on that. We don't care as much about how perfect that looks. And you see that a lot of games, and that's another way to get efficient. And so just to kind of think about that, where that plays in to what you're doing, if you have to have the best, clearest rendering for an entire scene, that might not be a hardware thing. That might be a software decision, right? How do they want to optimize their code on a graphics card? Some of that stuff's being done before you even have an option to buy a 20 RTX or a 2080 Ti or a 2060. The software is limited, and we've seen that. I think not to get away from it, but like Recap Pro is a program where Autodesk made a decision you can only use 40% of your system's RAM. They did that so the file doesn't blow up and you crash your computer. Frustrating thing about that. Well, that's a limitation. If you have 128 gigs of RAM because you want to accelerate your point cloud processing, you capped out about 50 or 60 gigs, which some people would say is a bad thing, but that's a software company making a mindful decision to maintain performance across everyone's platform. So I think that's what we get a lot on this is it's how well we can use the hardware. Sometimes it's limited to the least powerful user, right? So they're going to make the software run where if you don't have a designated graphics card, it'll be great, kind of what Matthew's talking about, but you're going to need one at some point, right?
Right. Yep. All right. Well, we're kind of coming up to the end of time here. Actually, before we get completely done here, Matthew asked another question. He asked the question, what about real-time ray tracing? Another rendering type question here in some of those graphics engines. And again, that's going to be very heavily GPU based. And I believe the Quadro is going to handle that far better than the GeForce is going to handle it.
We'll see. I'd say as of today, when the ray tracing cores came out, we haven't seen in a lot of these real-time rendering engines have come out and said that they're not optimized for RTX yet.
Right.
It's going to take them a year or so. So it will be interesting to see, but I don't think we've had a real good chance or someone's had time to optimize their system for the RTX cores. But it will be. And when they say optimized for that, those cores, and that's kind of what the GPU is, it is optimized for a specific data set to hit it and process it extremely quickly, right? That's why it's so much faster than a CPU. It's not a general task tool. It is very specific. Anytime we get NVIDIA creating and designating specific cores for a specific task, once the developers optimize their solution for that task, it's going to be beautiful. So I'm looking forward to it.
Yeah. So honestly, we don't have enough data yet to understand the full real-time ray tracing effect, but my guess is going to probably be Quadro in the future. But we don't know yet. We don't know. So. All right. With that, thank you all for the time you've given us today in talking with us about graphics cards. Next time around, we're going to be talking about the motherboard, the foundation of the system, and bringing everything together. So that's going to be in, 2 weeks, I believe, on Friday, just like usual at noon. So tune in then, and we'll be talking motherboards. Buck, thank you for
Anthony will be back. Yeah, Anthony will be back for that, and there is no one in the world that knows more about motherboards than Anthony.
Right.
He is the expert. So if you have any questions about motherboards or connectors or outfittings, whatever the configuration you might be, bring them and please be prepared to ask Anthony, man. He is a bank of knowledge.
Absolutely. All right, Buck, we'll see you in a little while.
Awesome. Talk to you, Shawn. Thanks.
Catch you later.